So I'm going to show you a couple of examples for how to set up your Galileo as a web server. We're going to use a technology called Node.js. I'll explain a little bit about what that means, what it is, and then yeah, I'll show some examples of how you might use this in your project as a control interface from the web, and also as a way to see data over the network. So, yep. So what is Node.js? Basically, it's a type of web server. It's not a full web server like you might have heard of Apache or Nginx, which are used to host very large websites. Instead, it's intended to be something very lightweight. It's a JavaScript runtime, which means it's basically a program that takes in a JavaScript file and then uses that to do the necessary web routing to serve up files over a network. The main difference between Node and other types of servers that makes it a little bit more lightweight and ideal for the IoT type application is that it's single-threaded instead of multi-threaded. So this one here on the left is traditional server. You have a whole bunch of different requests. These are people trying to get on your website. The server creates an individual thread to handle each of those requests and send a response. Instead, Node has one singular thread that it uses to run its server. Then that thread can process multiple requests at the same time. So why might that be advantageous? That's the scalable bullet point here. The single-threaded architecture will be much lower for memory usage, which makes it ideal for running on a platform where memory is a constraint, like your Galileo. Of course, there's some potential problems that can crop up. What if one client makes a gigantic request, or the request takes a long time to execute? That would be a problem. And what if there's a core exception? This basically means that one user on your server could potentially crash the whole server if it's not written properly. So there's various ways of handling that problem. There's things like process monitors that can make sure the server doesn't go down. But some other advantages of Node.js include the fact that you're writing your server in JavaScript and you're writing, theoretically, your client in JavaScript, the stuff that your user sees. So all the coding can be done in the same stack. That has a lot of benefits in terms of programmer sanity. There's also there's some other advantages, like the fact that if you're sending JavaScript object notation files between client and server all the time, you don't have to constantly waste time changing the data format. There's even databases now that can use JavaScript object notation. So there's this vision of like an ideal pure server configuration where server, client, database are all in JavaScript. And again, yeah, it's fast at certain things, especially if I/O is likely to be your bottleneck. And examples of that would be queued inputs or data streaming or WebSockets. And I'll show some examples of that also. So yeah, great for lightweight real-time tasks like Galileo. Okay, we did this, sort of. So one thing that you can try, the image that we included in the SD card has Node already installed, and all the examples I'm going to show. So if you want to make sure it's working, you just do node -- version. Node also has an interactive shell that you can try. So if you just type node, you'll get into the shell, and then you can kind of just play around with any JavaScript command that you want. The hello world example is doing console.log hello world, which will print that, and also the return value, which is undefined. And yeah, Control D to quit, or Control C twice. Control C twice. So what I'm going to show in a lot of these examples are pre-written servers, which you can also use as an argument to Node. So once you have your server written, you just do node, then file name of the server. So that file, hello.js, is hello world, so it's not a real server, but I'll show in the examples how we can launch an actual server. So there's a package manager for Node called npm. And again, you can check if that's installed and working. If you run it on your machine, you should be able to see a bunch of stuff that I've already installed. And we, again, put it on the image already because the network is slow. And installing packages with npm can be slow, especially in Galileo. So that's already done. You don't have to worry about doing this clock correction thing since you don't need to install anything. That's what it looks like if you do install, but again, you don't have to do that for right now. So here's the meat of what we're working on, writing a server. So the basic job of a server, of course, is to take in a request and give a response. The HTTP module is the most basic way to accomplish this in Node. So the file, by the way, all the examples for this are in the Node.js folder in the home directory of your Galileo. So the server basic JS example is this. The way you import a package in Node is to just say require and then pass in the name of the package. And you can set that to be an object that you can then call functions on later. So here we initialize an HTTP object. We then initialize a server object using http.createServer. And the input argument there is a function that will handle both request and response. So we say http.createServer function of request and response. Response, we write to the header 200, which if you're not familiar with, 200 is the HTTP status code for OK, everything is working. And you can say the content type is text/HTML. You actually, this is optional. If you don't do this, your browser will be able to figure it out. But that's kind of the proper way to do it. We then write to the response, Galileo server, and then response.end will close the connection. And also, if you don't, that's also optional technically. If you don't do it, Node can kind of figure it out and close the connection when it's not being used. So once that's done, we do server.listen, and this is the port number. So traffic over a network is going to be divided into many different ports, and different applications can run in different ports. 80 is the standard port for web traffic, which means that if you go to the IP of your Galileo in your browser, after this is running, then you'll see a page that just says Galileo server, basically. And here, we're just basically debugging, so you can see this on your Galileo shell. So yeah, you would call that node server basic.js, and it will run forever and just continually take in these requests and give responses until you kill it. Yeah?
Okay, so basically in the response right, where it says Galileo server, this is where it puts all the code we want to appear on that page, right?
Yes, but I'm going to show another way that will make it a little bit cleaner so you don't have to fill it up with HTML. So that's what it'll look like. I'll show some examples. I have one running a server right now, but that's basically what you would see. So this gets at what you're referring to. Eventually, once you have very large websites, it would be very inconvenient to put the entire content of your page in that response.write. So the way we handle that is by using a templating engine. The most common one for Node is a package called Express. It has a lot of other features as a web application. It can do things like logging and I/O a little bit better as well. But in this case, its main use is to be a templating engine, which means that we can serve up instead of writing the response individually. We can create templates and then fill those templates with whatever data we want. There's many different types of templating engines that you can use. You may have heard of some in the past. We're going to use one called EJS, but Jade and Hamel. They're basically like HTML-like languages that are designed to have data thrown in. So these are the changes we'll need to make to that initial example. So we're going to, instead of doing HTTP, we're going to do Express. So you do var express equals require express. You then can create an app object just by calling express. Here we're setting a parameter of app called view engine. And we're going to say EJS, which means it should take in the EJS files as views and use the EJS module as its interpreter for those views. We then call app.get. The first argument is going to be the routing path. So here when I just have a slash, that means if we go to the root directory of the server, here's what it should show. You can have other routing paths which will show as well. That would be, if you wanted to have another page like /status or /chart, something like that. So similar syntax, we also pass in a function to handle the request and the response. And here, instead of directly writing the response, we say response.render. Index will be the name of the template or the view. You'll see in the views folder, by default, we'll look in the views folder for any template of this name. So you'll see one called index.ejs. So by saying index, we're saying use index.ejs. And here are two different arguments that we're going to pass in. We're going to say parameter title should be home, and message will be message. App.listen, that's the same. Then in index.ejs, it looks like HTML. Very simple page, except this is where the EJS comes in. The % equal, you can then pass in a parameter. So here this is telling it, look for a parameter called title, and put it there in the page, and message, put it in the page. So I'll show you what that looks like. So there it's like a slightly more formatted page. So this way, if you have a header or something that you want to reuse, you don't have to keep doing that over and over again. So now I'm going to introduce a topic called sockets. You may have heard of this protocol before. WebSockets is a very old protocol for full duplex, meaning bidirectional two-way communication between server and client. There's, again, a couple different options for doing this, but the most common one for Node is called socket.io, and it's quite simple to use. The modifications that we make to the server to use it, again, similar syntax, we're going to say var io equals require socket.io, and then we actually attach that to the server object that we created before by using the .listen function. So then basically what we do is we have event handlers for any incoming traffic over that socket. So here we're saying io.on, first parameter is the name of the event. Connection will be any time someone connects to the server. We then have a function of the socket as the second input argument. So here again, this is console.log. I'll show some examples of this, but you might want to be alerted if the user is connected. And then socket.on, you can pass in additional argument, and this is something that may be coming from the client. You might look for an action called myAction, and then function of the message of that action is just to print out to the console, woohoo, meaning it worked. And then in the view, so I've defined a separate view for this example. So you have to include socket.io.js, which is the client-side version of socket.io. As long as you have socket.io installed in your Galileo, it can serve that up automatically. So here we just gave it a relative path. Initialized by just saying var socket equals io. And then you can do stuff like socket.emit, and that would be your action name. So actually, I'll show a live example of that. So I have, so this is my Galileo, which, you know, I sacrificed some goats and got it on the Wi-Fi. So that's actually been working pretty reliably. So I am running node server socket.js. And this is what that socket template looks like, or the action.ejs template. So when I click the button, you can see woohoo gets printed to the console. So pretty simple. Okay, so now a slight detour. I'm going to show you basically how you would interact with I/O through the kernel, which is what you would typically want to do if you're using, you know, some language other than something where there's already a package provided for you. You'll notice the examples that I use for Node.js will actually use a wrapper called Galileo IO, which I kind of discovered after I wrote this, that someone had made a nice little Node package for Galileo. But just kind of to show you what's happening underneath. So there's a virtual file system in all variants of Linux called sysfs, which exposes many different parts of the hardware to the kernel. So this allows us to interact with sensor data and I/O directly from the command line. So, for example, the Arduino emulation portion of Galileo is basically, you know, complicated wrapper calls that are interacting with those files to get the status of the different I/O pins, read from the ADC, things like that. So a quick example that you can do is read the core temperature, which is stored in a file, sys class thermal zone 0 temperature. You might notice it's a little bit hot. You might have noticed that if you try touching it too. Quark does run a little bit hot, but it's pretty high end, so it's able to handle that pretty well. So here's an example of how you would do basically just a digital write. The first thing you have to do is export the port, and actually you won't have to do this on yours because the image that we have given you is already taking care of that. But you first create a file for it in sysfs. You can set the port direction similar to how you do pin mode in Arduino. You just do that by echo out into the direction file, and then you can echo 1 or 0 to turn it on or off. This GPIO 3 is actually connected to the onboard LED, so if you just want to blink an LED from the command line, that's how you do it in Galileo. So here I'll show you an example of reading from the ADC. So a lot of the I/O pins in Galileo actually run through a multiplexer because Quark itself has fewer I/O pins than some of the other Arduinos that use the same footprint. So to connect up the ADC to the right I/O pin, we first have to set that multiplexer pin. So that's basically how you do it. That's very similar to how you would do it for the LED. Then there's a device in sysfs for the raw input voltage from that ADC, which you can read directly. So you'll notice if you do it from Arduino, it may be slightly more accurate. There's a little bit more that you can do from the command line to do things like temperature compensation, which I won't show you. But that's basically the most simple example. So in Node, if you want to do anything like that involving the file system, there's a fs library, and again, this would be exactly the same thing. You would say var fs equals require fs, and that's example how you would read the admin password. And yeah, as I mentioned, there's a nice npm wrapper that someone wrote recently to do a lot of the simple stuff, digital reads and write, analog read and write, which will help make this a little bit cleaner. But you might want to resort to this sort of method if you wanted to do things like use the UART or the SPI or I2C. So here's an example of how we would read that ADC measurement and include it as part of our node server. So one additional change that we need to make for this server is a static content folder to serve up the client-side JS. Here we need some client-side JavaScript to make the pages render a little bit nicer. We'll see the example, but it's basically a constantly changing number, and I've used jQuery for that. jQuery, you might have heard of, very common client-side JS that makes a lot of basic interactions manipulating websites a lot easier. So in the server, we say var Galileo equals require Galileo IO. Initialize, again, just the Galileo function, and set that to the object board. You'll notice that notation is very common when working with anything in Node. This is to serve up the static content folder. You can just say app.use express.static dir name plus the folder you want. You might want that also if you have a static HTML page you don't ever want to change the content of, or an image or something like that. You could create a similar folder for images or assets or whatever you want. And then to read from the ADC, it's board.analog read. They try to basically copy the Arduino syntax as much as possible. So here, this will basically continually pull pin A0. Again, pin A0 because it's actually something different in sysfs, but it's what Arduino calls pin A0. We can process a function. We can process the new data in a function. And here in my function, I've just said io.emit. This goes back to the sockets example. io.emit first will be the name of the event, which I've called data, and then pass in the data. And then in the view, basically, I have a socket to handle that incoming data. So for event data, the function of that message will be to take this div that I've given ID of data and replace the text with message. So I'll show an example of that. So I'm going to kill that server and switch over to a new one. And it takes a few seconds for the server to get going. Okay, there we go. So you'll see also it's now using a new template. So that's my object data, and right now I have my Grove shield in, and I have the actually the rotating switch connected, but you could use any of the other analog ones. The light sensor works for these too. So as I twiddle the switch, you can see the number change. So that's that. I'm going to show one more example too, where I've kind of improved this a little bit. So I like to use this library chart.js, which can create very simple line charts, bar charts, pie charts. You might also be interested in d3.js, which has tons of very, some of them can get very complicated, but there's simple ones as well. Lots of examples for data-driven documents, so it can be many different types of plots. So in server.chart.js, I added in a new route, /chart, which will kind of do a live view of that. So I'll show how that works. So basically it's just getting this continuous stream of new values over the socket, and basically adding them to the chart. So you get this is useful for like live data feeds or anything like that. So I hope it's useful. Feel free to use any of these examples as a starting point. They can be very useful for things like status pages. You just want to quickly check on the status of your application. That action template may be very useful too if you want to, start or stop something very quickly. And, well, I think, is everyone able to get the slides from the stick? Did anyone not get those?
Yeah, distributed them.
Okay. Well, so they're also on, I put them on my GitHub. You can also view the examples if you want to view them in a text editor or something other than your SSH into your Galileo. Feel free to go in there. Okay, that's it. Any other questions?